today we're going to learn about exponents and the laws of exponents. So everybody knows what exponents are, correct? Okay, so we'll just go over it real quick. If you have a to the n, that's like saying a times a all the way till you hit n. Okay, so you multiply it that many times, correct? Everybody knows that part? Okay, good. All right. So, the first law is going to be fractional exponents. So, we'll start over here. First law. So, when you have a fractional exponent, so you have a to the n over n. So when you have a fraction like that as the exponent, you basically convert it to a to the n, and it's the nth root. Okay? So obviously we'll do some examples so that you guys know what I'm talking about. So 4 to the 1/2 would be a would be 4 to the first and the square root. So what is that? Does anybody know?
4 1/2.
What is the square root for?
2.
Great. So it's 2. Okay. Does anybody have a calculator with them? Okay. Bella, you're going to be my helper, so whenever I ask you to do a calculation, you get to do it. Okay. So now let's consider 27 to the 1/3. Bella, can you do that in your calculator?
Yep. Make fractions on this calculator.
Would you like some help?
Yeah.
Okay. So when you're worried about fractions, or that we go 3 to the 27 to the
Oh, okay.
you understand?
Okay, yeah.
So it says it's 30. Awesome. Now I also want you to put in your calculator. So we got that as 3. Now I want you to put in your calculator the cube root of 27. Can I do that one?
9 times 3 is 27.
Okay, so both of them are 3. So does everybody understand this concept?
Yeah.
Okay, so we can move on? Yeah. Good. Alright, so the next law is negative exponents. So for negative exponents, if you have a to the negative n, all you do is you write 1 over a to the n. So if I had 2 squared, to the negative 2, what would that be? Who wants to give it a try? Yes, Bella.
1 over 2 to the second.
Which simplifies to what?
1 over 4.
Correct. Okay. And now on your calculator, can you do 2 to the negative second? Oh, yeah.
Negative 4. I think I just did that. 2. 2. 2.
So 0.25 is the same as 1 over 4. let's do one more example. So let's say 4 to the negative 3. Can you calculate that for me?
Zero point one five
0.15.
six two five.
Okay. Now, somebody tell me what this would convert to as a fraction. Yes, 1 over 4 to the third. Now, can you put 1 over 4 to the third in your calculator? So 1 divided by 4 to the third.
0.15625.
Is equal to 0.15625. So they're the same, correct?
Yeah.
So everybody would agree with this law as well?
Mhm.
Does it make sense?
Yeah.
Okay, perfect. We can go on to the third law, which is a to the m times, oh wait, hold on. Multiplying exponents with the same base. Okay, what does the same base mean? Does anybody know? Yes, Jesse.
Like the same base means, like the same number in front of the exponent.
Yes.
Like
Perfect.
1 squared times 1 to the 4th, like 1
Exactly,
is
so
the
the
base.
ones are the same, perfect. So, that's like saying a to the m times a to the n. Okay, now first before I tell you the law, we're gonna work it through first. So let's look at 2 squared times 2 to the third. Now, that is also like saying you have 2 times 2, and then you have 2 times 2 times 2, correct? How many 2's do I have there total? 5. So 2 to the fifth. What is 5 in comparison to these numbers?
Which is equal?
Hmm?
32.
No. Like when you're talking
2
about
plus
2 and
3
3.
plus
Yeah,
5.
exactly.
Oh.
2 plus 3 is 5. So with this example, what do you think the law is? Yes.
It's exponents,
If the base.
if they have the same bases, you just add the exponents.
Exactly. So when you have the same bases, all you do is add the exponents. So it would be a to the m plus n. So we'll try another one just to make sure we all get it. So 3 squared times 3 to the fifth. Does anybody want to come do it on the board?
I just have a question.
Mm-hmm.
What if the same exponents have different bases?
Okay, that's a great question. So let's think about it. So let's use this example. Let's say this is 2 to the fifth, okay? So let's write it all out to to see what's going on. So 3 times 3, and then everybody agrees that it would be 2 times 2 times 2 times 2 times 2. Okay, can you do anything with that in comparison to exponents? Can you group them together? No, because they don't have the same base. So all you would do is multiply these and multiply these, which is still the same as 3 squared times 2 to the fifth. So at the end of the day, if the bases are not the same, you can't add the exponents. So they have to be the same, okay? So we'll try it with 3 to the squared times 3 to the fifth. Okay, who wants to volunteer to come to the board? Go. Would you mind writing it like that so everybody can see what we're trying? And then what does that simplify to?
Oh.
Yeah, you have to calculate it. Perfect, 3 to the 7th. Because 2 plus 5 is 7, and you can see there's 7 3's there. Thank you, Bella. Perfect. Does everybody understand this law? Yes? Everybody's got it? Good. So we'll go over to here. Alright, so now we're going to do dividing exponents with the same base. So, dividing exponents with the same base. Great. So, that's like saying a to the n divided by a to the n. Now, if I make it, when you're saying divided, that's the same thing as saying a to the m over a to the n, correct? Did everybody understand that part? Okay, perfect. So, again, I'm not going to tell you the law yet. We're going to try and work it out first. So let's say we have 3 to the 5th divided by 3 squared. That's also like saying, how would you put it in fractional form? Does anybody know?
3 over 5 over 3 over 2.
Perfect.
And don't you just like subtract 5 minus 2?
So let's 3 times 3 times 3 times 3 is 3 over 3 times 3. Now,
So it's
how many
3,
3's can I cancel out here?
2,
Perfect. So I go like that and I go like that. How many am I left with?
3.
3. So that's 3 to the 3rd, correct?
Mm-hmm.
Okay, so what did we do with the 5 and the 2 to get the 3?
Subtracted
We
it.
subtracted. Perfect. So it is a to the m minus n. Now let's think about it if, so this, in this one, this number was bigger than this, correct? Okay, let's look at it if it's the other way around. So 3 squared divided by 3 to the 5th. Who wants to try and work it out on the board? Chelsea, come on. And then just write it like I did that, but you can write it away.
So it would be like 3, negative 3 if it's on the bottom, but you can't have a negative exponent on the bottom. So the answer would be 1 over 3 to the 3rd.
Perfect, exactly. So he used 2 of the laws here. Not only did he use this one, but he got 3 to the negative 3rd, which as you can see is 3, and there's 3 here. So the law is a m minus n. Obviously, if m is less than n, you're going to get negative, so you're going to have to put it into the fraction. What's that?
What if it's not the same base?
Okay, so if it's not the same base. So let's look at 3 to the 5th divided by 2 to the 2nd. So that's like saying 3 times 3 times 3 times 3 times 3 all over 2 times 2. Can you do anything to cross out those numbers? No. So you have to leave it as 3 to the 5th over 2 squared. And then obviously you would just compute that in your calculator. So that is that, but there is more. So everybody understands this one, correct?
Yeah.
Okay, so okay. Okay. Powers to a power. So that's like saying a to the n, and then you're multiplying it to the nth power, right? Okay. So we'll work through an example and then we'll try and figure out the law. So 2 squared to the 3rd. That's like saying you have how many 2's? For just the first part, ignore that. 2. So you have a group of 2 times 2. Now when you say to the 3rd, how many groups of these do you have? How many groups would you have?
Oh, 3.
3. Perfect. So you have 2 times 2 and then 2 times 2. So that's 3 groups of 2 times 2. How many 2's are there?
6.
Perfect. So it's 2 to the 6th. What is the relationship between the 2 and the 3 and the 6? Bella.
There's the power to the power you multiply the exponents.
Perfect. So 6, 2 is 2 times 3. Perfect. So it would be a to the m times n. Simple. Okay, perfect. So would somebody like to try this one on the board? So look how I did it with groups. I'm gonna try and do it the same. Perfect. So the 2, the 4, 2 times 4 is what?
8.
Perfect. Thank you, Bella. Okay, so everybody understands that when you have a base with a power to a power, you do what?
And then multiply.
You multiply the powers. Perfect. Okay, now we're gonna look at the last one. Okay, for this one, we are going to learn how to multiply powers of different pieces. So that's like saying A to the M times B to the M. So in this case, let's think of 2 squared times 5 squared. So what is 2 squared?
4.
Good. And what is 5 squared?
5.
Which is
100.
correct?
Yes.
Okay. Now, what is 100? 10 squared. Perfect. So 100 is also equal to 10 squared. What is the correlation between the 10, the 2, and the 5? 2 times 5 is equal to 10. So what, can someone tell me what the law they think would be?
You multiply the bases together and then use the same exponent when you get the answer.
Perfect. So it's A times B to the M. Correct? Okay. So that is the law for that. So let's just do one more example from there. And 3, 4 to the third times 2 to the third. Okay. What is 4 to the third on your calculator?
64.
60. And what about 2 cubed?
8.
What is 64 times 8?
512.
The cube, that is also equal to 8. Okay, now do 8 to the third. Because we multiplied 4 times 2,
512.
512. Perfect. So you get the same thing each time, correct? Awesome. That is the last law. The only thing is there is a special case in exponents. And it's just when you see it, you always know that anything to the 0th power is 1. So even like a huge number like 3,214 to the 0 is 1. Bella, do you want to put that into your calculator just to verify?
Yep.
It's 1. Correct. Okay, so whenever you have an A to the 0 power, you get 1. No matter what A is, you will always get 1. That is a special case. Yes.
What if you have 3,214 to the 0 times 5 to the second? Do you add the sums or do you add 1?
So you're
Or do you
saying
just like multiply by 1?
3, 2, 1, 4 to the 0
Mhm.
times what?
Like 5 to the second or something.
5 to the same. Okay. Are the bases the same?
No.
Are the exponents the same?
No.
Okay, so you don't have anything to do, but if you have this problem, what does this go to?
1.
So it's the same as 1 to 5 squared. So that's 25.
25.
Perfect, exactly. So because you don't have the exponents are the same, and you don't have the bases the same, you can't do anything about it. So that was a good question. Alright, does anybody have any questions overall? Okay, great. So now we're just gonna try a small worksheet that uses all of them. It's only 10 problems. So if you need any help, just let me know. And when you're done, you can raise your hand and I'll collect it. Do you need help, Jessica?
I'm just looking at it.
No problem.
I'm done.
Awesome.
Thank you.
Thank you. It's okay, take your time. Thank you. Okay, does anybody have any last questions that they came up with on the sheet, or did everybody understand?